Assalamu alaikum wa rahmatullahi wa barakatuh, ladies and gentlemen. So, today we are here to explain the multisim and the tinkercad circuits. Before getting on that, let me explain about the project and what we have. Here we have a bicycle. The bicycle have 5 lamps L1 and L2 and L3 and L4 and L5. As we increase the speed, the lights will turning on. For example, if we have low speed, L1 will be turning on. I increase the speed L2, I increase the speed L3, and more and more. So, what will happen if I didn't have any speed? There is no motion, then there is no lamp will turn it on. So, to get the Boolean expression and the gates and the tinkercad and this all stuff, we should firstly do the truth table. So, how would we will do the truth table? Let me explain how we'll do the truth table. So here's the truth table that we generated. We have 3 inputs that will act as switches, A and B and C. Furthermore, we have 5 outputs L1 and L2 and L3 and L4 and L5. So here's the truth table. After doing the truth table, we have did the K-map. Good for the lamp 1, L1 equal A plus B plus C, L2 equal A plus B, L3 equal A plus B plus C, L4 equal A, and L5 equal A times C. So this is the Boolean expression. How we will do the gates? How we will connect the gates in the multisim? To do that, firstly, we should know what's A plus B plus C represent. Here's A and C as an input because we have plus here that will be OR gate and the output will be L1. It will be connected with a resistor to save it, to keep it alive. Moving to L2, we have A plus B. Same story. We have OR gate here with 2 inputs and the output will be L2. Here we have a different story. What we have is A times plus B times C. How can we do this expression with gates? So here we have B times C. We can represent this by AND gate. So if I put 2 inputs B and C in AND gate, the output will be B times C. Then this output will connect it to the input of the second OR gate. So we have here OR gate and we will connect the output of the B and C. Then I will connect A as an input. Then the output will be A plus BC. Easily L4, nothing to do, no gate, it is connected from the switch to the resistor and then the LED. Lastly, L5. L5 A times C, that represents AND gate, and 2 inputs A and C, we will get output with AC, which is L5. So let me move to the multisim. Basically, here's the multisim. We have a voltage supplier with 5 volt and connected with 3 switch A and B and C. As we mentioned that from the K map, we got L1 equal A plus B plus C. And we said that we were represented by OR gate. So here's L1, A and P and C will be connected as an input with OR gate, then the output will be L1, but we connect here resistor to save and keep the LED alive. For the second LED, here's L2, we have A plus B from the Boolean expression. A and B, to make it plus, we use OR gate. Here we will have A plus B, and that is L2. But also we connect a resistor to save the LED. For L3, we have a different story. As we said, P times C will be represented by AND gate. Here is AND gate, P and C. That will make P times C. So to get A plus P times C will connect it to OR gate, and here we'll connect A, that will give me A plus P times C. Before we get into the LED, we will connect resistor also to save the LED. The easy part is L4, because there is no anything, it's only A. We'll connect switch A with a resistor with LED. That's it. Moving to L5, here's L5. L5, we connect A and C with AND gate because it's A times C, and the output will be A times C, and here we also connect a resistor to save the LED. Before moving to the tinkercad, because we will use two ICs in the tinkercad, and they are contained AND gate and OR gate, we should understand the behavior of each one. When we move to AND gate, we have the name of the IC 7408 and AC. So here the IC, the first pin is VCC, which is power. Then input act as output, two inputs, and then output, two input, and then output, and two input with the output and ground. So basically we have four AND gates with two inputs and one output. Moving to OR gate, the name of the IC 7432 or IC chip. Here is the IC. Like the AND gate, have a power supply and here a ground. Then we have four OR gates: input, input and output, input, input and output, input, input and output, input, input and output. So let me move to the circuit here. So this one is the OR gate and this one is the AND gate. So L1 was A plus P plus C. We'll assume that A is 1, B is 2, and C is 3. So L1 equal A plus P plus C. The plus tell us it is OR gate. So we will move to the OR gate, which is this one. So as it's shown here, L1 equal A plus B plus C from the Boolean expression. Here is the first input. Here is A, which is 1, P, which is 2, and C, which is 3. But we can't put the third input, so we will link the output as an input here, and then we'll take the C. Then the output we will connect it to L1. This is for the first lead. So the second lead was L2 equal A plus B. So here is A, which is 1, here is B, which is 2, and then the output will be connected to what? To a resistor, then L2. Moving to L3. L3 is A plus P times C. So we have a plus, it is OR gate, and B times C, it's AND gate. For L3, here's the first input for the AND gate. It is connected to 2, which is B, and here it's connected with 3, which is C. For L3, L3 equal A plus P times C. P times C, which is AND gate. The IC of AND gate, this one. So here input P and C. This one P and this one C. So the output will be connected with OR gate. Here is connected it with OR gate. The second input will be connected with A. Here is with A, and that will make A plus P times C. Then the output will be connected with L3. Here with resistor and simply with LED. So for L4, nothing to do. Here is L4. It is L4 equal A. So we connect switch A as an input to the output to the LED 4 with a resistor to save it. Moving to L5. L5 has two inputs. A times C. This one A, which is 1, and C, which is 3. And that's it. The output will connected with lead 5. Now we have complete explained how is the connection was. Let us move. If we open the switches, how is the circuits will act. Firstly, we start simulation. All of the LEDs turn off. When only C is high, only C, which is 3, is high, L1 will be turned on as expected. When input B is high, L1 and L2 will be turned on. Input B, L1 and L2 as expected. When both P and C are high, L1 and L2 and L3 will be turned on. P and C. Here we go. As I said, when input A is high, L1 and L2 and L3 and L4 will turn on. Let me check. Is it clearly shown that L1 and L2 and L3 and L4 is turning on? When both input A and C are high, all of the LEDs should be turned on. A and C. It's clearly L1, L2, L3, L4, L4 is high. That was our explanation of the multisim and tinkercad. Thank you.